Alrighty, so if anyone doesn't know me, my name is Neil. I'm a tech lead here at foundU. And today we're talking about the joys and perils of single tenant database design. This is kind of a branch off the roundtable that we had, I think, last year, on how we deploy and manage our environments. So I'll be going through what sort of different tenancies there are. There's a whole different combinations and stuff, how you can set it up. I'll just cover three and then how we use them. So let's get into it. So if you've used any cloud-based service, chances are you're using some sort of tenancy on that service. So for example, if you're using Google Cloud, AWS, you're a tenant on their infrastructure. You've got your own isolated section which you can build upon and use as you like. So infrastructure, platform, and software as a service. Just a couple of examples there. Different types of tenancies. So that should be on the next window. Okay. So different types of tenancies. You've got a single tenant. So you've got your application and infrastructure layer on your in isolation, basically. So it means you've got dedicated database, you've got dedicated application code, dedicated servers. Most common would be like an enterprise sort of thing. So you want your own infrastructure. You don't want to have, impact your service based on other customers' requests, load, et cetera, et cetera. And then you've got your multi-tenant application. So the application itself is shared. So the code and everything is still share the same thing, but your data is stored in a separate database or a separate schema or whatever. But you also use the same servers to run that code as well. Potentially, there's obviously a hybrid model you can also use. And then you have a shared multi-tenant application. So this one is where you've got all your code, all your data on one separate data layer, separate application layer, but it's all in the same server. So you can go have Google Slides, potentially run the same application code on the server, and your data is stored in the same database, except for your account, you're given like a unique ID. It could be good, it could be any sort of identifier. And that is then used to basically limit access to your information. So if you log into your account, and then let's say Nathan logs into his account, he can see his data, I can't see it, but I can see my own data. So that's obviously one other type you can use. So yes, this is a little diagram just going through. So basically, yeah, you get customer A, customer B, complete isolation. So customer A will not impact customer B and vice versa. If customer A is compromised, customer B is left alone. Obviously, given you don't share the same username and password across servers, which some people might do for ease of use, but security standpoint, not the best idea. It's fully customizable because you've got your own application servers, you've got your own databases. You could pay a little bit extra. For example, I know there's some companies out there for enterprise that might give you customizability. So you can do, custom features and things that are specific to your business, but they don't impact anyone else. It is a lot more maintenance. So given you've got different set of servers, different set of databases, different application code, it's a lot of work to manage. So that can get really expensive as well in terms of maintenance, but also running costs. So if you've got specific set of servers for one customer, then you got to duplicate for another customer, you're basically doubling your cost there. And chances are a lot of the server power is not being utilized. So you're paying for tenancy or paying for servers that you're using 2% at your peak, but you just don't use anymore, for example. So yeah, it gets quite expensive. Obviously, depending on the business, it might be viable, but yeah. Next thing is multi-tenancy. So with multi-tenancy, somewhat similarity in the data layer, the application itself is shared. So Google Slides. Example here is, using the same application code, but my data is stored separately. So you could do two things. You could either have entirely separate database servers, or you could have separate schemas living on the same server, and you still have isolation, somewhat isolation there. Obviously, if your application code is compromised, it's shared across all of your customers. But if your database is compromised, then it's only accessible to that specific customer. It's a little bit less maintenance, especially on the application side. You're maintaining one code base, but then it's still a bit of a maintenance job on the database layer, because then you have to manage those individual databases. It's a lot cheaper to run on the server level, even on the database level as well, depending on how you set it up. Individual servers will be more expensive. 1 or 2 servers, like distributing your load, but individual schemas per customer, that will be a bit cheaper to run. So it just depends on what rate you take. And then you have a shared multi-tenancy. So this is kind of a hybrid between, well, it's still multi-tenant, but everything is shared. So the previous example, you could have chosen to have separate database servers. This one, it's in one server. So you've got everything sitting on one same application code base, same database server, potentially the same schema. This is where you would use something like a tenant ID or a GUI or some sort of a global identifier to say, okay, I've logged in as customer A. I should only retrieve data for customer A. You can't customize anything. So code is basically the same across all customers. Your database layer is also the same. If you need to have that, you probably should be using a different tenancy system, either in isolation or complete separate servers. It's less maintenance. So you maintain one application, one schema, basically. And it's a hell of a lot cheaper because you then distribute your processing power across all your customers. The other thing with this is if you have one customer that is taking a lot of processing power away, you get what's called like a noisy neighbor effect. So if you've got a really large customer and you've got this really small customer, and this really small customer, for whatever reason, has a sudden spike in usage, that really big customer will see the effects. Using the same servers, same database, they could be running a really, really large data extraction process in a small customer, and then the big customer comes and like, oh, my system's running really slow. That will be pretty much why. And then what do we do? So we kind of take a mixed approach. All the same application code, database servers, same, to a degree. So prod testing, they're completely separate. Testing database, you could do whatever you like to it. If something goes wrong during the migration process, or if there's this sudden load. So if we're testing a feature where there's some really heavy queries, we're not going to impact any production customers because they're in a completely separate server. What we do with this one is we actually have different schemas for each customer. So we still have multi-tenanted, but on a schema level. Same database server, same application code, same application servers, except on the schemas, we can run them separately. So what does this let us do? So I mentioned during our roundtable back in 2022 is that we have different global branches. So we've got our production branch, we've got staging branches, and we've got testing branches. So testing branches, they have their own dedicated server that runs. They connect to a testing SQL database, and they run in complete isolation. So we could be testing one Peril feature on one server, and then we have another Peril feature completely separate on another server. So it's good for that isolated testing. With our master, so production, same sort of deal where we've got one code base, and then we've got all our databases running on a production cluster. With staging, this is where we got a few questions come through, is that how do we move our live customers off to a staging run for a beta release? This is where having our schemas set up separately, or schema per customer set up. So it gives us a lot of different information I'll speak into soon. But basically, just as like a quick summary, is if we need to move a customer A over to a beta feature that's running on a staging environment, separate code base, separate application service, but the schema doesn't move. The schema stays where it is. It's the same database. The only thing it changes is where this traffic comes from and where we serve the traffic to the customers. So I'll go to that in a second. And another thing here would be, how do we manage our deployments if we have separate schemas for everyone? You know, we could have 1,000 customers. We need to migrate the database across all 1,000 schemas. So we utilize queues quite heavily, mainly because it lets us manage all our migrations on a per schema level. You're not running them all concurrently. I'm sure if you do a load test, you run 1,200 customer migrations, large migrations all together. Database is probably going to go down. Too many connections, right? So what do we do with this? So we still use Laravel. So Laravel is still used as the core framework, but they've got basically an environment per customer. So what I mean by environment per customer is still Laravel, is that we generate env configs for each customer. So unique credentials, any other unique prefixes and things, database credentials, all that stuff's all unique, random generated, and then we push that out to the server. Now, with crons and queues, we don't use schedule run, we don't use your queue work like normal. We have this smart script that we wrote up, and what that does is basically goes through a round robin. And what it'll do is it'll hit Redis, right, or whatever SQS or Memcache, any other in-memory database for queues, and it'll pick out, okay, what do I have in my queue to process? All of your environments have a prefix. So if you've gone to your Laravel configs, you go to your database, you'll see like a Redis key prefix. That's always unique prefixes. That basically means you've isolated it into that specific customer. So if one customer pushes one thing to a queue, that does not pick up and process under another customer. So what that basically, the QWorks smart script reaches into Redis, says, I've got customer A, B, C, and D. Just randomly pick one out, right, and process it. So there's no like one favorite customer. There's no order of a customer. So if you have an alphabetical order in your Redis and your customer starting with Z, you're not going to go right in the back of the queue every single time and wait for hours for your work to process. It's always going to pick out randomly. With scheduling, we actually wrap around what Redis and Laravel's queue worker does, how it pushes work to the queue. So all our scheduled jobs run on a queue. Nothing presses on that server itself. Reason for that is, as you scale, you can't process that much work on one little server. Given, obviously, scheduling, you can only execute once. You add more servers to scheduling, you're going to have a lot of duplications to deal with. So, yeah, that's kind of how you manage. Is any questions about this sort of process or inquiries?
How do you handle the requests coming through and pairing them to the live?
Yeah. Yeah. So a DNS, so obviously we've got a DNS with all those subdomains. We use subdomains to basically identify the customer. So if you've got customer A dot foundU, whatever it is, that is then directed to that load balancer. And if you have customer B, but they're on a staging environment, that customer B subdomain is directed to the staging load balancer, and that web traffic goes straight there. To identify what customers are running, we basically use like these blank files and just name dot like a random extension, temp, block, whatever. That determines what's running on that environment.
So there's a there's a hook inside of Laravel called like dissect environment,
Mm.
and that's something that you can override which env file loads. And so in that we just basically look at the subdomain and go, well, this subdomain I'll load 30 dot blah if it's available. Otherwise, I'll load the base env.
Yeah.
And that's on every request.
You don't have like a separate load balancer per customer.
No.
All the subdomains for every customer go to the one load balancer,
Yeah.
except for like your staging.
Yeah, so if it's a production system, it'll go to the production load balancer and they'll direct the traffic to whatever instances are running in that scaling group. And then if you're running on a staging environment, it'll point to those staging set of servers. So
You can make like a production customer actually run on like your staging server and still do like their
Yeah.
full day-to-day
it's just
work.
where we direct the traffic from, and then the queues basically detect, hey, this is the customer that's running on this server. I'm going to process that work. So if I were to move customer A to staging, there's a whole process, automated process base says, okay, send a request out to the production server, tell it, I'm not going to serve you traffic anymore, but tell the staging server to serve the traffic or accept the traffic, sorry. And then I'll update my DNS entries. And then the queue servers also have this little script running, being say, pull down my environments. What am I running? I'm not running customer A anymore. Same thing happens on the staging. It'll pull down whatever customers are running. And then as soon as that switchover happens, okay, I'm running customer A. All right, I'll start processing work for that. Yeah. So the schema just stays where it is.
Pretty seamlessly, except for the fact that you're using a domain name. And if they're like caged, so the customers with Optus and Optus hold the things for a really long time, they'll be still pointing at the production system, even though, so it's not exactly perfect.
Yeah.
But given that we only move someone to staging like once every so often, every few months, we might spin up a staging environment. It's not that big of a deal.
Yeah. It's usually when there's a lot of like breaking changes. Really good example, Laravel PHP upgrade. That was one we definitely had to use it for. So yeah, so there was a stage rollout. So we still have production people running on, PHP, was it 7.1, 7.2, something like
We
that?
don't talk about We're all running.
Yeah. Oh, sorry, PHP 8. Sorry. We didn't jump 5 versions. But yeah, like that's the idea behind it.
Yeah,
So-
anything that you can't use a feature flag for because you fundamentally changed the structure of the database or something like that, the feature flag just doesn't work, or the Laravel upgrade, something like that. It's really, really helpful deployment strategy. Just getting one customer across and they're like, it survived. No, interesting.
Oh, like the first pancake, I get it.
We have a very selected platform that we
I was gonna ask, why do you have customers running on staging? It sounds like for testing.
It's for early release
Yeah.
of things.
It's
Yeah.
to limit like really bad, really negative impacts on the system. So if there was something major that happened, it's only restricted to that, not the thousands of other people that are running on the system.
Yeah, say you've got a customer and they're like, I desperately need this feature, and you're like,
Okay, it's gonna cost you.
there's a bit of risk here because if we get this wrong, we might not pay it correctly for other customers, et cetera, et cetera. It's like they're willing to stomach the risk that is, if it doesn't work, like it's just one customer. And let's say it's not something that you can control with feature flag because you fundamentally need to change the structure of the database or something like that. Then having the ability to put that on a staging environment, put that new branch, like basically this production plus a new feature on there, and just move that one customer across and see what happens. And then you move 10 across and you see if their payrolls are affected or anything like that. And then you might release it to production and then move it back.
Yes, it's a stage rollout, essentially, like beta release,
It's
essentially.
not something we intentionally designed that is flagged. Like,
Yeah, this was just by chance.
the whole point of the system was never actually to sell to anyone. It was to make their own business really efficient. So it was single tenant by design. And when I first got in, and I was like, we're gonna get rid of this. Like, we're gonna bring everyone together. All that stuff. But there's some serious upsides to it, and that's one of them. That we've learned to exploit the upsides and try and limit the downsides. But yeah, sorry.
Yeah, all good. So yeah, did anyone have any questions about the queue? How we process that? Did I cover that? All good? Yeah. All right. Cool. So yeah, what are some of the possibilities that we can do with this? Hang on, one window. Presenter mode isn't even active. So yeah, as I mentioned, stage reliable releases, isolation scenario testing. So because every customer has got its own schema, we can actually pull down that schema, restore into a testing environment, strip out all the personal information, and just run tests. So, for example, let's say a customer comes up to us or sends a ticket in saying, "Hey, my Peril isn't working," and we go and have a look, and we look at all our test systems, all the other systems. It's definitely working. Why is it not working for you? So rather than going to the live environment, tinkering around with settings, potentially breaking, potentially paying, people that shouldn't be paid by accident or rostering people, we can actually pull that data down and restore into a testing environment dedicated for that purpose, which still runs the same code, which again, separate schemas. And then we can go and tinker around with it. If we accidentally break the entire thing, all right, we'll just wipe it out and restore it again. And then we can also restore into local environments as well. Again, removing PI information. What that lets developers do is they can then test their features before it even hits QA. So they can test for labor hire businesses, they can test the direct employers, they can test the different rostering setups, without having to go in, writing scripts to tweak all the settings and all that. We've got so much data that we can use. We can pull that config down, the setup for the customers, and actually run our tests against it. And then for disaster recovery is also a really, really important one, because with the database servers, if something goes wrong and you have to roll that data back, it's not just that one customer, it's the entire server. All the data on that server gets rolled back. So we have customer, we get a really big customer and say, "Oh, I've just broken my entire system. I've deleted everything. I need everything back." Whereas most of the time you can just restore like soft deleted data, but then if it's like really, really bad, that's when you can go and restore that one customer only and not impact anyone else. So that's also a really good scenario that we can basically put through, given that the schemas are isolated and not one schema with a tenant ID. What are some drawbacks? So it's not all sunshine and rainbows. Large migrations do take time. So given how big the migration is, what sort of data is migrating, there's a certain process that we would follow, especially with really big tables. With databases, when you add a new table, it has to re-index the data or resort the data, or whatever it needs to happen. It could be really heavy in I/O. And if you do it during the day, obviously you're going to have some performance issues there. So ideally, migrations get released ahead of time, especially if they're backwards compatible. So if it's adding a new column there, we just go and, hey, release the migration, let it run on the queue. And then once that's done, then we can go and roll the application. That's mostly when the queue workers are dependent on that call. If there's a web server only, like a user front facing item only, then we can kind of roll the migration out depending how big it is with the application code itself. And then the second thing is managing the distribution of those tenants. So given, you could have a really, really over-provisioned server for 2 years, but you've only got 5 people on there and they're pretty small. So instead of doing that, what we can do is then, okay, well, we can boot up one server. We'll give it X number of resources, and we'll make everyone create a new platform. When the request comes in, go to that one server. And then over time, we add another server as you grow. And then we can put smaller customers on a different server. We can kind of distribute everyone based on, if they're a big customer, if they're a small customer, who's on there already, who's not on there, plan for future customers as well. So, and the other thing is, if the customer really, really wants it, they could even have their own database server themselves and just have them on it. If there's like a 50,000 person business, really, really big business, and they want to have their own database just for performance point of view, it's a possibility. You could even do that. But then when you're writing queries becomes complex. So if you're gathering data across all your systems, so let's say we want to determine how many wages were paid across all systems for the financial year 2023 and 2024, you actually need to go into your system and actually query that data out. If you had one database in there, you could just write a query by hand, go in, write it up, execute it, you pluck it out, because all your tenants are in that one table. Given you've got different schemas now per customer, that becomes a challenge. So you have to figure out a way to get through that. So that's also another downside with that one.
How do you?
So the orchestrator has access to query the platform, so we don't reach into the database directly. There's like an internal application that goes in and reaches out, say, hey, I'm going to send you this query. Can you execute this for me in the read node and bring me the data?
Like SQL?
It goes through all of
Yeah.
queries. Yeah.
Yeah, and like you could output it as CSV, JSON, like whatever you like, basically. Yeah.
Yeah. Looking at different ways to do that, and it's just not an easy problem. Like I talked to Amazon about it, and I was like, "Is there something we can do with the backup service for Aurora or something?" They're like, "I think it's just a fucking mess." But okay, so let's stick with our homegrown clutch thing.
We don't have just like one database server with like 1,000 schemas, one for each customer. You have like a bunch of database servers, and you can move your customers between them.
Not move the customers to the databases. We can move customers' application, like what they're running. The schemas, once they're created, they stay there. They don't go anywhere. Yeah.
You could.
You could. Yeah, you could if you wanted to, exactly.
Downtime or whatever. But
Yeah.
Yes. you could.
Dumb question, but all the schemas are different.
No.
Okay. Oh,
They all stay in sync.
same. Okay.
So that's the other
I
thing.
was wondering,
Yeah.
how you did migrations across.
Yeah. So on the release, all the same application code runs. Obviously, if you're running production or if you're running staging, if the staging code is different, obviously that's a separate thing. But if you're running production, like we did a rollout, I think last night, adding a new column into one of our tables, deploy it. The deployment process basically goes through the cron server. The cron server detects, hey, there's a migration to run. I'm going to push out a job into the queue for each of my environments, and that's going to start processing the queue. There's no custom Laravel trickery, all that. Like if you were to move this application as it is to a single Laravel environment, like our local environments, there's basically no difference. You can't tell what's happening with it. That's a false second. So yeah, it still works exactly the same way. Anything else?
There's another pro of like from a development point of view, it is quite nice not having to worry about like tenancy while you're designing your application, being like, oh, what context am I in right now? Because it's like you literally can't go outside the bounds of the current.
Yeah, you're locked in. Your environment variable, basically, your environment variables are for that one environment. Yeah.
But your con, right, is that you can't build in this architecture, you can't build features that are set up by like, like labor hire, someone's just create an account and then all your customers can access that.
That
So
is
like,
a challenge. Yes.
Yeah, so if you've got one business who's got like 5 different environments, and those 5 different environments just can't communicate to each other because they're complete isolation.
Yeah, and that is a drawback because like it locks our usage of services to kind of IO based services where they're really dumb and they don't store any information, because otherwise, like all the information for the customer needs to remain in the core schemas for that customer. But otherwise, when you do a backup restore or something like that, and then you go to access it and it's not there under the new subdomain, it just causes a whole bunch of complexity. So
It's kind of one or the other.
yeah, I best describe our architecture as like a service assisted monolith, but that's a threat. So like for example, our services that exist will just be IO. They'll do virus scanning and they'll just take a file from S3 bucket and spit it back a result, or they'll do a Vigo check or something like that. They just do one thing and then it's a dumb service. Just relay. And then they talk back to the host system and say, oh, this was the result. Like,
So we've got a couple of smaller services that act like that, basically. tenancy, but they're not a tenancy. They just have a column in there saying this is the environment name that it belongs to. And the request that comes in is from the environment itself, and then just send a reply back to that environment only.
Yeah.
How long does like a regular migration take?
A few seconds.
Like to run across all of your schemas? Oh,
Yeah.
do you
Depending
need,
on how much, sorry?
why do you need queues for that?
So queues for that is basically, so we don't want to process it in line. So this basically it's, we've got dumb servers essentially, right? So those dumb servers, I think I've got that somewhere. Yeah, so we've got the dumb servers. Basically, they're isolated to do one purpose: web traffic, scheduling, or queue processing. Now, the cron server, the scheduling server itself, on deployment, because we got one server, one cron server running, that handles migration jobs. So, and the other thing too is we don't boot up the environment to actually push those jobs out. So when you push something to a queue, you go dispatch and then the class name. It does none of that, or schedule run, -env, whatever, right? We've actually kind of dug into how scheduling works on Laravel and the actual job dispatching process, and actually just wrote a little script around that. So we actually reach straight into Redis. So with the migrations, it's like a migration job. So the queue server handles the grunt on like migrating columns across. What that means is if the queues are, like if there's a lot of load on the queues, the first thing it'll do is process those migrations. The only reason we do that is because if you start booting up the environment and you run db migrate for 1,200 people, 1,400 people, 20,000 people, you're basically going to need a really, really beefy server. Booting up Laravel takes a bit of resources. So that's the main reason why I pushed out to a queue to process that load. Because the queues are round robin, it'll just go through and randomly pick out whoever's got work to process, just process it, either till it's empty, or I think it's a limit of like 5 or 10 jobs, I think, per one worker, and then die down, does its garbage collection, and then goes back and says, okay, I've got more work for another environment, and I'll process that. So yeah, does that kind of answer?
If you're talking about a case where you have a migration that has to run before like your UIs change or something like that, we'll actually send the migrations out early in their own PR. And be like, off you go do your thing.
I think I was more asking like, why isn't it just part of CI? Why does it have to be like a job?
Definitely because it ran out of memory. Like
Yeah.
the cron server is a tiny little thing.
Yeah.
And it like basically would have this CPU graph. We'd have to pay for like a double XL server. And it would just go
even that wasn't enough.
flat, and it'll go, and then flat, and then another deployment.
Yeah.
And it was like, why are we paying for all this CPU basically?
Columns.
So it was pointless. So we're like, well, we've got all these queue services sitting there, like they're beefy servers, they can handle in the framework 100 times over. Like that's not a problem. So that's when we started.
And because with Laravel, you can define different queues. So you can have like a default queue, which is just queue work straight up. But then if you go with the queue parameter, you get like a high queue, a short queue for like really short jobs. So that's what we use with like really, really important stuff. That's where the migrations go in. Then do a high queue. If the high queue has a job, that's the first thing it's going to do before it does anything else. It's the most critical job to process. And then it'll go through and say, okay, I've got stuff in the default queue, I've got stuff in the short queue. So short queue is just like really small instances that process really, really quick jobs. Sending out text messages, emails, stuff like that. It just does not take that much time. So that's how that kind of goes through. All right, so how do we actually provision our customers? So as I mentioned earlier, we've got like this internal tool that we use. That internal tool communicates to the platforms. So the user from foundU sends a request saying, hey, I want to make a customer. This is a production customer, and I'm gonna give it a name and this subdomain, and then I'm gonna go submit. That then comes through to the system and says, hey, I've received this data. I want you to provision this server in a production environment. It'll then ping those production environments, the servers, and say, hey, here's a new customer. Here's the name. And then what that'll do is, okay, I've got a new customer. Cool. I'm going to pull down their config, credentials, the prefix of the database, whatever it is, subdomain. It'll go to the DNS server and say, hey, here's a new entry to add in to point to the ALB. And that's then done. And then I'm going to specify, hey, I want to create this customer off a template. So 99% of the time, kind of like a base scheme, which is basically empty, which is pre-filled with things like states, payroll tax, like the general payroll stuff that we need. That's across everyone. Or if you have like a business unit where you've got a huge business and they've got different units, they can have a main platform that they set up as like a template, and then they can use that template to create other business units in that company. So that's all that part of that process. Yeah, and the same tool, as I mentioned before, if you need to move to a staging environment, send a request through. All it does is changes the DNS entry and just lets the service know, hey, I'm not going to serve this traffic anymore. It's going somewhere else. Yeah, I guess that's pretty much it. Cool. Good. Any other questions you guys want to have?
You're starting again,
Mm-hmm.
knowing what you know, like there's
Yeah.
benefits and drawbacks. Like, what would you do differently?
I think probably pretty much almost the same thing. Maybe a few minor differences here and there. I think the sizes of a lot of the schemas can really grow out. So I think just planning out properly. I think when the system was initially made, it wasn't really planned out to be like a software as a service thing, just in-house. But yeah, I think having these isolated schemas, it gives you two things, especially like obviously security with like complete isolation. So if someone got one database credential, they're locked to that one database. That's it. They can't access the other 1,000 people that are on there. And then obviously doing the stage rollouts with it, having, like the Laravel upgrade is a huge example with this. If we were to do it, we have to cut every single customer over. If something went wrong, it basically takes the system offline. So yeah, and because with the system, there's so many different settings and all this different configuration that you can do, you can't test for 110% of everything that the customer does, or what you can think of. So like you go and do a scenario testing and like, oh, I've covered everything. 2 days later, there's a customer like, oh, hey, this isn't working. How the hell did you do that? So there's always different ways of doing it, but I think this is pretty powerful this way. It has its drawbacks, definitely, but I think it's been worthwhile. Yeah. Yep.
There's a number of the EC2 instances that we have versus the actual numbers of the database servers. Do we have like a perfect ratio? Because I remember you mentioned that if we have so many of the queue servers running and then trying to constantly writing and reading from the databases, they will have a lot of I/O.
So if you overload the database with if you've got 1,000 people running at the same time, and you boot up 100 different servers, and each of those servers process 100 jobs a second, you're going to start really loading the database. So there is a challenge there where you have to think about, okay, how far can I push the system to process concurrently on all my tenants without having negative performance impacts? Obviously, read-write splitting is a very useful feature in Laravel. A lot of the jobs that you would do, they would read a lot of data. Very few jobs actually go and write that data on there. So you've got basically a challenge there. Okay, I want to boot up this amount of servers. I'm going to see how it performs during peak days, and I'm going to tune it. But then, if you really need more power, you can go and upgrade your database to a bigger instance as well, which is actually not that hard, surprisingly. Amazon released like this blue-green deployment thing we use for Laravel upgrade from also updating a database version. It was 0 downtime on there. So you can go and change that sort of stuff too, but there's no direct relation between that. You just got to tune it, essentially.
So with the auto scaling, do we just implement the
Not infinite.
demand?
Not infinite. Yeah.
Just in case, something could go wrong with the scaling metric too. Like you log into the wrong file or whatever, and then all of a sudden, you get something wrong. Yeah.
Yeah. Like the metrics
You
are
always
the,
want to have up and down.
yeah, yeah. Billing is probably a big reason why. If you give it no boundary, it's just, you're going to rack up a huge bill, especially if there's a lot of customers sending out a lot, pushing a lot of traffic through. With queues, because the scaling is dependent on how many jobs there are on the system, not the CPU. So that's a recent change we made, because the CPU would just be sitting constantly because all the workers processing, but there'd be like nothing actually to process because it processes so quickly. And so the scale down event would rarely trigger. So instead of using a CPU, we're going to depend on how much work there is actually processed. If there's no work, scale down, like it shouldn't be running. But as soon as you get like today, yesterday, you get thousands of pay runs and all that, it starts building up. That's when the service can start scaling up. And once the work is complete, it'll wait a little bit just to make sure there's no spikes, and then it'll just shut down. So yeah, that took a while to make sure that's not going to overload the system, but we've had 0 issues on queues backing up, delayed work. So it's been working pretty well actually.
And we have had a lot of those issues in the past. Like it was,
Yes.
we had issues when we outgrew our Redis server,
Yeah.
which nearly was the death of me for 3 days. And things like that you don't expect to go wrong, and then once the queues get backed up, it just gets worse and worse and worse. And then yeah. So now our system's working quite well, but it didn't always work.
Yeah,
So,
it's had its challenges.
yeah.
Cool. I think that's it. We've gone well over time, to be honest. Yeah. Cool. Thank you.
Thank you.